Good evenings, Diane and Norlin, and also Nora here. Last week, we talked about the data analytics with the topics or special themes about the relationships. And in our uh, interpretations, we are looking for the definition about the regression analysis with the single regressions and also with the multiple regressions, and also conducting how to making some forecasting. And in this ones or in this course, we can start about the how to obtain the analysis with our data. In tonight, I'll only using about the data from 8.3 about the baseball salaries to show you how to combine about the data if you have some variation in your data. As you look at your screen, we have the several data from the 8.3, the data about the baseball salaries in 2015. There are some salaries from every positions, starting from the catcher, center fielder, design hitter, until to the third baseman. If we have lots of data like this one, and also with the difference of number with the observations, you can see about the design hitters, there's only 7 players, but we have lots of catcher data and the center fielder. Now, what if the question is, can you analyze the randomness about the salary between the player in the baseball for the first 50 player in our observations? We only analyze the first 50 players. So in these ones, we need to running about the data analysis using analysis of variance, because we need to know how variance our data it should be inflated or not. We can block with this our samples of data. For the question is about how to analyze the first 50 player. So we need to block the first 50 players, 50 player only. So it could be n in 51 because the first row is the label. And for the output, I will take it on this one, L2, L1. Okay, when you click the analyze, you can find but this informations like this one. This is the difference group of our analysis for the position in the baseball at the catcher, center fielder, hitter, and also with another player. We can find that hitter is the lowest of observations. It's only 7 player, and in overall they are in the 50 observations. The difference is only in the first baseman and the third baseman and the right fielder. They're between the 40 and to 50. So with these informations, we can conclude about the score in the p-value using a between groups in all of the samples, not by one, but this for all of the samples. It conclude that they have the difference of salary. So with these informations, we can estimate or forecast that between every position in the baseball player, they have a different salary. And the salary is very difference in range between every positions. This is the starting point when you have lots of data in variates. Any question about this data 8.3? No questions? Okay.
Sir, wait.
Yes.
What what is the difference between groups and within groups?
Between groups. Okay. Between
How
group
to
is
analyze?
okay. The between group is talking about the comparison of data between the group 1 in the catcher, center fielder, hitter, first baseman, and the left fielder. That is the between groups. While the within groups is the variance in every group. So in the group of catcher, we found 50 observations. In the 50 observations, they have several of examinations. They have the differences in the group. So there is the information about the between and within. So in the calculation of our analysis, it could be only in the between because it can be compared for another groups, not by some observation in the one group or in the same group. Is it clear, Norlin? Okay. Thank you for your questions. And the next for the next of the 10 is data 8.1. 8.1 is about the questionnaires data. In the questionnaire data, we have several informations about the number of observations, that only 30 observations. Okay? And then we have the data about the gender, 1 for male, 0 for female, and the state, the children, the number of children, and the salary, and also with the opinions. With this data, we can conclude or we can take only the several observations. Let's say that we only take about the gender, the children, and the salary. I drop this one first. Okay. So we only have 3 variables: a gender, children, and salary. You can make some differences like this one. What affect the salary of every persons? So this is one is the dependent variables, because we need to predict how much the salary for every person. Okay, what is the factor to create or to forecast the salary? We have 2 factors. The first one is the gender, and the second is the children. So this one is called independent variables. We have 2 x. In the common knowledge, we only name about the factor number 1 is x1 and factor number 2 is x2, just like that. Okay. So for the single regressions, we only have 1 independent and 1 dependent. So you need to choose about what is the one factor for salary. Let's say you have a children's and the salary, or gender and salary, just one factor. While we talk about the multiple regressions, while we talk about the multiple regressions, we need all of the independent variables. In our case, we only have 2 independents, the gender and the children's. Okay, let's simulate one by one. We start about the singles regressions. Okay, you need to go to data analysis and find about the regressions. If you find about the regressions, you need to input the first range. This is the dependence or Y range. Sorry. If I going back here, we have the dependence, and this one is independence. Okay. Let's start about the regressions. We need to input about the independence, the dependence variables. You need to drop or you need to drag out of the dependent variables. And if we talk about the single of regressions, we only have 1 independent variables. Which one do you choose, Diane, Norlin? It's a gender or children? Please choose one.
Children, sir.
Children. Okay. So do you expect that if every people have a salary is based on how many the children's? That's the
No.
factor. Or the gender. If the genders, so it means that you have you predict that the one genders is maybe higher than another gender.
Yes, sir.
Maybe, sir. Yes, sir.
Maybe, okay. Sorry. I have to, I lost this data. I need to copy this one. Okay. So for our analysis, what will the best options? Just choose
Gender.
once. Huh?
Gender.
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 Let's say about the gender. The dependent variable is gender. This one is single regression because you only have one independence with the label in the first one, and we need to drop the output range in here, and then this one is our analysis. We have the R square here, the multiple R. This is correlations, okay? And also the number of observations. We have the multiples regression score, and also with this one is the value about the gender. Okay, let's say that we have alpha or our interval confidence in is 5%. Okay, so if this score is below the 5%, it could be significant, but this is more than 5%, so this is not significant. Okay, you just say the NS, not significant. So in the one observations or in the single regressions, the score in here, it could be same with this one. Okay, the score here in here is similar to this one. It's identical because we only have one predictions variables. This is only for single regressions, but in the multiple regression, it may differ. Okay, so we start about this one, the correlations. The score of correlation is very low. It's almostly to 0. So they have a weak correlations. In other words, we can say that a gender is not affected by the salary. Male is not have higher salary than females. Sometimes the female is the higher than males. Based on our data, there is not inclusions. Okay, and the R square of the adjusting information is also very tiny, so we cannot conclude about the gender will affect it about the salary, but that's okay. This only for our exercise. Yeah, so we need to compare about the multiple regressions. What if our X variables or X independence variables is containing about the two observations, x1 and x2. And we have placed the score here. Okay, look at the score. I need to cover this one. The observation is clear. The score of F and for every variables is not equals. So you can see here that we have the correlations between our independence variables x1 and x2 is still low, but it's not too low, still low. It's between 15%. So I think they are more connected if more than one variables or one factor. So if you have the decisions, how much the salary for our employee, you need to thinking about the number of the children, the gender, and maybe with the another of several factors. The R square is also not tiny, it's in 2%. So gender and children is factoring about the 2% only. So we have 98% factor that not in our observations. It's too high. We only have 2% of the factor projecting the salary. So if you have to predict the salary more accurately, you need to find another factor that have a good effect or with the have a high of concentration for the R square. So for the score of the F value, it's still not significant. Where we have the 5%, is also still not significant. It's also similar to the gender and the children. They are not significant because only 2% to predict the salary. We need to have a more powerful factor that we can predict or we can forecast the number of salary that we need to pay for every employee. Okay. That's for the inclusions for our analysis. And if you compare this one between the score of F and T in here, it could be difference between the single of regressions. In the multiple regressions, they are not identicals. They have the difference. But sometimes if this one, if the F analysis is having a significant score, there must be one or minimum one variables that have effect, a good effect for our analysis. But in our case is we cannot find or we cannot have the evidence or the conclusions to ensure that the gender or children can predict the number or the how much the salary that should be paid for our employee. Okay. This is the step for the single regressions and the multiple regressions. After we starting about the ANOVA or analysis of variance, we can conclude that this one is very complicated than ANOVA. If you running about the regressions, you also have the ANOVA. But if you running about the ANOVA only, you only have this table. So regression is more complicated than analysis of variance or ANOVA. Okay, is it clear for Diane and Norlin? Any question about?
Yes, sir. None, sir. I don't have any question.
Thank you, Norlin, for responding. How about you, Diane? I think it's lagging. Any question, Diane?
None, sir.
Okay.
None, sir.
Thank you for responding. So this is the how to obtain in our next analysis about the relationships, how to conducting the single regressions and how to conducting about the multiple regressions and also how make some forecasting and the decisions analysis. If you don't have any questions, we need to continue our classes for next week with another subsections is about the optimization and for the uncertainty. In this case of regressions, we have the certain conditions. You can predict the salary maybe for the gender or children. That is the certain factor. But and for the next week, we need to covering about the how to make some prediction in if we have some uncertainty factor that we cannot control it. And statistic will only provide you or give you some evidence, but maybe there's not the first or the best options. You need to have some personal analysis or make with some decisions to creating a good for forecasting or maybe with adding with some assumptions to creating some forecasting analysis. Okay, I think that's all. I need to stop it first.